Hi, I'm Jonas.
And I'm Caitlin. This is our project over string theory. Basically, just a simple introduction. String theory is a fairly complicated topic, and since we don't understand the complicated bits anyways, this presentation will cover its basic aspects as well as fill in other parts of quantum physics.
Physicists today are trying to come up with a unified model, a theory of everything that tells us why everything does what it does in the universe. The closest we've come so far is with the Standard Model. It combines the electromagnetic, strong, and weak forces that govern our universe.
The main problem with the Standard Model is that it's not complete. Scientists have not been able to couple the theory of gravity and relativity to the Standard Model. This is why other theories, such as string theory, are being developed.
Einstein's theory of relativity posited that space exists as a sort of flat grid if no mass is present. When objects are instantiated, they pull down on the fabric of space-time itself, much like a weight on a blanket will pull down on the blanket. Through testing, the theory has held true, but it has been impossible to include it into the Standard Model. In the point particle theory, the elementary particles exist as spheres of influence, with rigidly defined locations and distances between them. But because gravity is a distortion of space-time itself and therefore the distance, no precise points or lengths can be used.
The Standard Model describes the motion and attributes of the 17 elementary particles. They fall into the categories of bosons, quarks, and leptons. Bosons represent weak force, quarks strong force, and leptons electromagnetic force. One attempt to include gravity in the model was with an 18th elementary particle, the graviton. But once it was added, the model fell apart due to gravity's incompatibility with the point particle.
What the elementary particles actually are, however, is a different problem. When we observe something, we are actually seeing electromagnetic waves go towards the object and bounce back towards our eyes. Remember the optics unit. Elementary particles are so small that most waves simply just pass them by. In order to make the waves small enough, they must have very small wavelengths, but therefore a very high energy. When these high energy waves hit the particles are altered. This explains Heisenberg's uncertainty principle, which states that we cannot know both the exact position and velocity of an object at any given time.
String theory is a unifying explanation of what the elementary particles actually are. Beyond point particles, string theory hypothesizes that each subatomic piece is composed of a string, which can be visualized as a high-energy filament. What separates one string from another is its vibration. A different vibration creates a different particle to be represented. This includes gravity, which is what makes string theory so elegant. Think of it like notes on a guitar or violin. Placing a finger changes the vibration of a string, and a different note comes out, just like a different vibration gives a different particle. If string theory can be proved in our universe, it would be a unifying theory dictating everything that happens ever.
String theory is full of problems that have made it a controversial idea in the scientific community from the start. First and foremost is the fact that the math that we can use to prove string theory only works if we have 10 dimensions present. Our own observable universe has only 3 spatial and 1 temporal. A solution to this obstacle is that there are more dimensions around us, but they exist as tiny, curled up dimensions that we cannot see. This sounds confusing, but you can liken it to an ant crawling along a string. When we look at the string, it appears that the ant can go only left or only right on the string, like one dimension of movement. But if you go from the ant's perspective, a much smaller being, the string can be crawled around circumference-wise, which gives us another dimension. The hypothetical extra dimensions are just like the ants crawling around the string.
Everything so far may seem both confusing and extremely theoretical. However, there are experiments underway that hope to either prove or disprove higher dimensions in our universe. At CERN and other colliders, particles are being rammed into each other at extremely high velocities. When a full-on collision happens, much of the particles are transformed into energy, while the strong and weak forces change. The theory is that given enough initial energy at the time of collision, some will be pushed into another dimension. Physicists are measuring the energy before and after the collision to check for any change. Due to conservation of energy, any loss of energy or mass would indicate that the energy has gone elsewhere, such as into another dimension.
Thanks for watching. We know string theory and quantum theory in general are extremely complex fields that can't really be explained from one video made by 2 high schoolers, but we hope that you at least have a basic concept of what string theory is and why it's important. Bye!